This is part 4 of section 1.5. We have talked about factoring a quadratic equation to solve, and that's great when the factoring is easy or when it works. We have the square root property, which is fairly easy, but things have to be written in the right form for it to work, so there's a drawback there. We have completing the square, which always works, but nobody likes. And then that gets us to the quadratic formula. If we start off with ax squared plus bx plus c is equal to 0, then we can use this formula right here to solve any quadratic, okay? You should memorize this. If you don't have it memorized already, you should do it right now, okay? A couple of things to point out. This fraction bar needs to be long enough. A common mistake is to let this minus b slide off to the side. If you do that, it changes the value of everything. The same thing with this radical bar. Make sure it extends far enough. I'm going to strongly suggest that you calculate these in pieces and not try to put the entire thing in your calculator at once. That's asking for major mistakes, okay? But I want to show you where this comes from. It's not just a formula that they give you and it's magic. What I'm going to do is I'm going to start off with our general quadratic, and I'm going to complete the square on it, okay? So the first step for completing the square is to divide everything by a. So if I have ax squared plus bx plus c equal to 0, and I divide everything by a, I end up with x squared plus b over ax plus c over a equals 0. Okay, the next steps are to get the constant alone, find the magic number, and add it to both sides. Okay, so right here you can see that I have the x squared plus b over ax, and here's this, I moved over here and it's right here. Now to find the magic number, I took the number in front of x, which was b over a, and we divide it by 2 or multiply it by 1/2. If you have a fraction to begin with, multiplying it by half tends to make more sense, and that gives us b over 2a. Now we have to square this. And you square the top and you square the bottom to get b squared over 4a squared, and then you add that to both sides. That's where we are right here. Okay? So this should be a perfect square trinomial, and it is. So it will factor as the square root of this, which is x. This sign, it's a plus, and then the square root of this. And by the way, what number goes right here is always the number, whatever is right here before you squared it. So you shouldn't have to do that thinking again. You've already done it. That's what goes right here. Okay, and then, so that's squared right there. And on this side, we need to get a common denominator, which would be 4a squared. So I'd need to multiply this one by a 4 and an a. And you can see here that I did that on the top and the bottom. You get 4a squared on the bottom, and then you get negative 4ac in the top here. So now combine these, and they have a common denominator, so it's b squared minus 4ac, which is what I have right here. Okay? Now our next step is to use the square root property on both sides. You can see under the square roots that I have the same thing I did on the previous page. Okay? If you take the square root of both sides, you have to remember to do the plus or minus. Okay? And then if you split it up, you can take the square root of this over the square root of this. The square root of 4a squared would be 2a, and so I just have the plus or minus up here with the radical. And then when you take the square root of something squared, you get this. Now to solve for x, you subtract this from both sides, and you can see that they have a common denominator already. And so when you combine them, you get to here. The quadratic formula isn't magic. It's simply completing the square and then using that answer over and over and over and over again. Okay? Okay, a couple of things I want to point out about the quadratic formula when it comes to using it. You notice that the initial equation is equal to 0. Right up here, it's equal to 0. If you don't have that, your a, b, and c are going to be wrong. So your signs will be messed up and it will change everything. So make sure you have that 0. I mentioned making sure your fraction bar extends all the way. Don't let the negative b slide off, okay? Double check that you have the plus or minus when you use the formula. It's easy to forget. And if you're in the habit of splitting up your answers in set notation, you will catch that mistake, okay? Just like when we're factoring, these problems are a lot easier if a is positive. So right here, if this is a positive number, it's going to be easier to work with. If it's a negative number, you can multiply everything by -1 and you'll have a positive number there. It's a perfectly legal move. Just make sure you change all of the signs, okay? And the quadratic formula can be used to solve any quadratic equation, but it's often more tool than we really need. If something's easily factored, going through the process of the quadratic formula is too much. It will work. You're going to do a lot of calculations you don't really need to, okay? But if my general approach is if I see how it factors, I do that because that's the quickest way. Then I look for the square root property. If it's in the right form for the square root property, I use that. And then I will go to the quadratic formula, okay? So let's work some problems using this thing, okay? So I'm going to rewrite the quadratic formula over here. Okay, and now we'll use this to solve these equations. The first thing we need is a 0, and we have that. Okay, so we look at our coefficients. Our A is 1, our B is 8, and our C is 12. And it's really just a matter of plugging in and doing arithmetic at this point. Okay, X equals -b, which means the opposite of b. So whatever sign this has, you write down the opposite. So this is +8, so I write down -8. Plus or minus the square root of b squared. You take your b, whatever it is, and you square it. Now I put this in parentheses because if your b happens to be a negative number, the parentheses matter. And so it's probably a good idea of just getting in the habit of doing the parentheses every time. That way you don't have to worry about it every time. Okay, and this is -4 times A, which is 1, times C, which is 12. And this 4 comes from the formula. Fraction of the radical bar extends all the way. Fraction bar goes all the way. 2 times A, which is 1. Now you want to start your calculations inside here. This part is called the discriminant, and it gives you a good idea of what kind of answers you're going to get. Okay, let's just do some calculations inside there. Okay, I have -8 plus or minus the square root of, that's going to be 64, minus 4 times 1 times 24 will be, times 12 will be 48. And this is over 2 times 1, which is 2. So this is equal to -8 plus or minus the square root of 64 minus 48 is 16. And this is over 2. Now I said that the discriminant tells you what kind of answers you're going to get. If this happens to be a 0 under here, then you're adding 0 every time. Really, you get one solution. If this is a negative number in here, you're going to get complex solutions. You're going to have I in there. If this is a perfect square, you're not going to have radicals in your answer. If it's not a perfect square, but it's positive, you're going to have radicals in your answer. And that's something to keep in mind, especially when you start working quadratics in the real world, like the ones that in application problems. We need to continue to simplify here. The square root of 16, we can simplify. This is going to be -8 plus or minus 4 over 2. And now we've done as much of the algebra and everything as possible. We need to split it up. I have -8 minus 4 over 2, which will be -12 over 2, which is -6. And then you have -8 plus 4 over 2, which will be -4 over 2, which is -2. So your two solutions to this quadratic equation are -6 and -2. Okay, so let's use the quadratic formula on 5x squared plus x minus 2 is equal to 0. Okay, our A is 5, our B is that understood 1, our C is -2. Make sure you keep up with the signs. They make a difference. Okay, so x equals -b, so -1, plus or minus the square root of b squared, minus 4 times a, which is 5, times c, which is a -2. And this is all over 2 times 5. So this is -1 plus or minus the square root of 1 squared is 1. This is going to be 20, -40. So this is plus 40. And this is over 10. So -1 plus or minus the square root of 41 over 10. Now the square root of 41 does not simplify at all. I'm not allowed to combine these. It doesn't simplify whatsoever. So your two answers are -1 minus the square root of 41 over 10 and -1 plus the square root of 41 over 10. Okay, one more. X squared minus 2x plus 17 equals 0. Your A is 1, your B is -2, and your C is 17. So x equals -b. This is -2, so I write down a +2. Plus or minus the square root of b squared, here's where those parentheses matter, minus 4 times a, which is 1, times c, which is 17. And this is all over 2 times a, which is 1. So what do I get here? I have 2 plus or minus the square root of -2 with the negative inside the parentheses squared is a +4. Minus 4 times 1 times 17 is 68. And this is over 2. Okay, so I have 2 plus or minus the square root of -64 over 2. And since I have a negative inside here, I'm going to have two complex answers. I'm going to have an I in there. This is 2 plus or minus the square root of 64 is 8 and an I over 2. Okay. Now this can be simplified. There are two ways to think about this. The first method would be to factor a 2 out of this. And I get 1 plus or minus 4i over 2. And then these 2's can cancel out. The other way of thinking about this is to split it up into two fractions. This is 2 over 2 plus or minus 8i over 2. And then you reduce each of these to get 1 plus or minus 4i. Either way, your answers are 1 minus 4i and 1 plus 4i.